Problem 6. This problem 6 has three parts. First, we are proving the part A. Show that x is equal to 2 e power 40, y is equal to 3 e power 40, and x is equal to e power minus t, y is equal to minus e power minus t are the solution of homosystem, and dx divided by dt is equal to x plus 2y, dy divided by dt is equal to 3x plus 2y. Now we are solving that A part. Solution starts here. The given homosystem, we are writing these two, dx by dt and dy by dt, and considering it as an equation A. Now we are taking x is equal to 2 e power 40 and y is equal to 3 e power 40. That is given in that question. Now we are differentiating x and we'll get 8 e power 40. Now we already know that dx divided by dt is x plus 2y, and we are substituting that value here. 8 e power 40. Now we are separating this into 2 e power 40 plus 2 into 3 e power 40, which also gives 8 e power 40. We are separating this into x component. Since x is equal to 2 e power 40, we are separating that into a part where 2 e power 40 exists. Now we have a conclusion that dx divided by dt is equal to x plus 2y. Now we are taking y. Y is equal to 2 e power 40. Now we are differentiating y. We'll get 12 e power 40. Now we know that value of dy by dt, and we are substituting that. Now our y value is e power 40. So we are separating this into two parts, by which we will get 3 e power 40. So 3 into 2 into e power 40 plus 2 into 3 into e power 40, where we can find this 3 e power 40. Now dy by dt is equal to 3x plus 2y, as given in that question. Now we are taking that our solution is x is equal to 2 e power 40, y is equal to 3 e power 40 is the solution of A. We proved that first solution in that A part. Now we are taking that second solution. We have to prove that this is also a solution of A, equation A. Now we are differentiating x e power minus t. By differentiating x, we will get this. We know that the value of dx by dt and we are substituting that, and we'll get the value minus e power minus t. Now we get this value. Now we are taking y equal to e minus e power minus t, and we are differentiating it with respect to t. We already know the value of dy by dt, and we are substituting that, and we'll get a final value e power minus t. Here also we'll get that our solution x e power minus t and y minus e power minus t as a solution of that equation A. The proof of A part is over. Now the B part. Show in two ways the given solution of a system in A are linear independent in every closed interval, and write the general solution of the system. Here we have to prove that the set A, this set, is a linearly independent. Linearly independent is nothing but if at least one of a vector in the set can be defined as a linear combination of others, then the set is said to be linearly independent. Now we are considering Odinary formula, that is W equal to modulus x1 x2 and y1 y2. We know that value of x1 and y1 and x2 and y2. So we are substituting the value, and by evaluating the modulus we will get minus 2 e power 3t minus 3 e power 3t, and the value is minus 5 e power 3t, which means W not equal to 0. Again, consider the equation. Since W is not equal to 0, we are again considering two equations. C1 plus x1 plus C2 plus x2 is equal to 0. C1 y1 plus C2 y2 is equal to 0. We know that value of x1, x2, y1 and y2. So we are substituting those values. After substituting, we are solving those equations, and now we'll get the value of C1 and C2 is equal to 0, which means that the solutions are linearly independent. Thus the solutions are linearly independent. So the general solution of a system A can be taken as, now we are taking that general solution of a system as x is equal to C1 x1 plus C2 x2, y is equal to C1 y1 plus C2 y2. Now we are taking these two equations as the general solution of system A. The B part is also over. Now C part. Show that x is equal to 3t minus 2, y is equal to minus 2t plus 3 is a particular solution of non-homogeneous system. C part, we have to prove xp is equal to 3t minus 2, yp is equal to minus 2t plus 3 in a particular solution. Dx divided by dt is equal to 2x plus 2y plus t minus 1. dy by dt is equal to 3x plus 2y minus 5t minus 2. We are taking it as an equation B. Now xp t is equal to 3t minus 2. yp of t is equal to minus 2t plus 3. Now we are differentiating xpt with respect to dt. With respect to t, we'll get 3, which is a constant. Similarly, we are differentiating yp of t with respect to t, we'll get minus 2. Now we are taking this equation with suffix p and we are substituting these two values. By substituting and simplifying, we'll get answer 3. Similarly, we are doing in this second equation. And now we get minus 2. Now dy p of t divided by dt is equal to 3xp plus 2yp minus 5t minus 2. This is equation 2. And dx p of t divided by dt is equal to xp plus 2y p plus t minus 1 is the equation number 1. Now, by comparing these two from equation 1 and 2, we'll get that xp is equal to 3t minus 2, yp is equal to minus 2t plus 3 is a particular solution of non-homogeneous system. Since the above system is non-homogeneous, it is a particular solution of a non-homogeneous system. Hence, the general solution of B. In this two equations, we have to substitute the respective values of x1, x2 and xp. Thus, we get two new equations and that is the solution.